I'll subscribe though, if you subscribe today.
All right, so arc length of radian measure, okay? So we want to find the length. How do you find the length of an arc? Okay, so what is an arc, right? We've already talked about that, but here's another definition of it. An arc is an unbroken part of a circle consisting of 2 points, called the endpoints, and all the points on the circle between them, right? So we can talk about arc AB, okay? Arc length is understood to be the distance along a circular arc measured in linear units, such as like feet or centimeters, okay? So here's how we're going to do that. So for example, in this picture, right, we have an arc AB. We know the measure of arc AB is what? 60 degrees, right? But we're going to now find the arc length. So in other words, if we were to actually make this circle so that it has a radius of 9 centimeters, we're going to actually find the length of the arc from A to B. If we actually were able to measure from A to B, okay, we could find its actual measure. Okay, what was the comment?
We're going to do the Pythagorean theorem.
Not Pythagorean theorem. What we're going to do is first find the circumference of the circle. Okay, so circumference formula, right? C is 2 times pi times the radius. So in this case, what is our radius of the circle? Anybody?
Above the radius squared.
That's pi times the radius squared. That's for area. For circumference, it's just 2 times pi times radius, or pi times diameter. You can do it. So again, what's the radius here in the circle? The diameter is 18. The radius is what? 9. So we'll do 2 times pi times 9, which is equal to, did you get that? You said, Khalil? 56.5 was what we'll round that to? Approximately? All right. Thank you, Miss Tammy. Yeah, if you don't mind real quick, and then I'll get those out to some people here. Thank you. Okay, so now that is the distance around the outside, right? That is equal to 56.5, and I guess in our case we'll say centimeters. Okay, so that's the distance around the outside. All right, but what's the degree measure around the entire circle? 360, right? 360 is the whole distance around. But we don't want the full distance around. We want this 60-degree angle. So what fraction is 60 of 360? Or how can we come up with a fraction for that? Thank you. Uh-oh. These are like in, oh my goodness. They're backwards. No, you didn't. It printed out in a funny order for some reason.
Oh, okay. Here,
So I gotta fix it. Yeah, if you don't mind. It's like, so basically, I think each page needs to be flipped. So that should be 863, then 864, then 865, then 8. So all of them need to be like flipped. If you know what I'm saying. The page numbers will help guide you. All right, sorry. So again, what fraction is 60 of 360? 1/6, right? If you look here, the entire circle is 360 degrees. Therefore, the arc's length is 60 3/60ths, or 1/6 of the circumference. Right. So fill in the blanks to find the arc length. So the arc length AB, okay, is 1/6 of the circumference. We're going to do 1/6 times 56.5. Okay. So 1/6. And put that in parentheses, sorry, times 56.5 is 9.4, we'll say, 9.4. Okay, which I don't know, they give it to us twice, so we're going to write it twice, okay? So it's about 9.4 centimeters. Okay, again, the whole way around the circle is 56.5, that's the circumference. We only want this fraction, which is 60 over 360, okay, 60 3/60ths, so we do 60 3/60ths of 56.5, we get 9.4 centimeters. Okay, so the arc length of AB is 9.4 centimeters, and we're not going to worry about the other part there. Okay, so there it is. All right, questions on any of that? We're basically taking the circumference. We're taking the circumference and we're multiplying it by the fraction of the circle that we want. Okay, so if we turn the page here, we're going to skip that little reflection question. We're going to turn the page and we're going to look exactly at that formula. Okay, So there's our formula for arc length. Okay, oops. Okay. Arc length, and for some reason, S, the letter S is used to denote arc length, but this is our formula right here, okay? It's the measure of the arc, so in this case, we just call it M, measure of the arc over 360 times 2 times pi times the radius, okay? All right, wonderful. Thank you, Miss Tammy. Appreciate it. Okay. So there you go. Anyone else need a copy? Oh, we're on the next page 864. Okay. So let's look at an actual example here. All right, so the example says, again, we're on page 864. On a clock face, the minute hand of a clock is 10 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 to 12:15? Okay, so again, our minute hand starts at 12 o'clock and it's going to travel down to 12:15. Okay, so what is the measure of that arc in degrees? How many degrees is that from 12 to 12:15?
80.
How much?
80.
Not 80, close. It's 90. That's a fourth of the circle. So we'll say, okay, so then how far is that? Well, 90 over 360 times, and then we're going to multiply by the circumference. So what's the circumference? 2 times pi times, what's the radius of the circle this minute hand is traveling? Well, how long is the minute hand? 10 inches. So we can just multiply by 10. That's the radius. Okay? So we take the circumference. There's the circumference right there. That's like if the minute hand were to travel the full distance around the outside of the circle, circumference. And we're going to do the fraction 90 3/60ths because it's not going the whole way. It's only going this fraction of the way. Bless you. Okay, we type it into our calculator. So you can type in parentheses, 90 over 360 times 2 times pi. You can use 3.14 if you want to, times 10. They get about 15.7. I'm going to use the squiggly equal sign because we're rounding here. So 15.7, and then it's going to be in inches because the minute hand was in inches as well.
Would that mean rounding the squiggly?
Yeah, this means that's approximate.
I thought that's
Approximate.
similar.
No, similar is one squiggle. One squiggle.
It's so many like
I know, right? It's like learning another language.
squiggly.
All right, let's try another one here. So now the minute hand of a clock is 6 inches long. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 to 12:30? Okay, 12 to 12:30. So now we'll think, all right, from 12 down to 12:30, what degree is that arc? What's the degree measure of the arc? From 12 to 12:30, what's the degree measure of that arc?
180.
180, a half the circle. So we'll say 180 over 360 times, 2 times pi times, now what's the radius of this circle? The minute hand is no longer 10 inches long, it's now what? 6, so times 6. Okay. So 180 over 360 times 2 times pi times 6. So about 18.8 we'll say. And again, that'll be in inches. Okay, just type it in the formula there. Questions on any of that?
Inches.
Say again?
Inches.
It's in inches, that's right.
Wait, so you always do two, you just do
The circumference formula.
you do the, what is that, then you do the degrees it's going, like, of the arc,
The degree measure of the arc over 360
the whole length is
times the entire circumference. Because basically, when you're finding arc length, you're finding a fraction, a part of the circumference.
Are you always doing times
2
2?
times pi times radius. Right? Because that's circumference formula right there.
So, how do you know the radius?
Well, the minute hand of the clock is 6 inches long to the nearest tenth of an inch. How far?
The length of,
Right, because the minute hand, right, starts at the center of the clock and it goes to the edge there.
so the length of, like, whatever item in the universe will be the radius,
Mm-hmm.
and then and then you do 2 times pi times the radius.
Mm-hmm. And then the fraction of that radius. So because the minute hand's only traveling from 12 to 12:30, so from 12 all the way down to 12:30, that's 180 degrees.
That's the same for all of these problems.
For the clock ones, yeah, for the clock ones, yeah. So, in fact, I want you to go ahead and try here, number 3. So, on the next page, the top, the minute hand of a clock is now 8 inches long to the nearest tenth of an inch. How far does the tip of the minute hand travel as time progresses from 12 to 12:45? So, you'll have to figure out what that degree is, okay? So, from 12 to 12:45, okay? So, if you need to look at the clock up there, or you can look at the clock on the page right here, but we're going from 12 around this direction all the way to 12:45, which is right to here. Okay, so again, you can look, go ahead, try number 3, come up with the arc length that the tip of that minute hand is traveling. And don't forget the arc length formula is right here. M over 360 times 2 times pi times r.
Dude, U mark is awful. We just, like, I put 5, but, like, U mark is always, if we put 3.14.
No, that's fine if you use 3.14, because that's approximation of pi. Okay, so I'll come around and help out as necessary, but go ahead and try number 3. Take like a minute or 2 here, try number 3.
I think I get that.
Okay? Try number 3. Try number 3. Alright, try number 3. Mr. Stark.
Is there a pi line on our calculator?
There is, yes.
Oh, I can never find it. I don't know, like,
It's right there.
Oh, you just have to.
For a second. So you're going to try number 3 here, and we'll go over it together. Try number 3. If you need some help, let me know. Alright.
I absolutely understand.
Good. Try number 3. So, 45 degrees, it would be 45 if you're going this direction, but the minute hand travels this direction, right? So if that's 45, actually it would be 45, it would be 9 degrees, right? There. So how about this? Degree measure?
Wood.
9 degrees. Then how can we find this measure? Oh, yeah. Right. Well, no, I always thought it was 12.5. So yeah, from here all the way around to 6, and you want 8, we can go this much further. So then when you add, that was 9. You got the 9, right? Then it was 9. Chris, question. He goes right to 12. 5 times 8. Yeah. Correct. Solid. Like one more minute here, one more minute. We'll go over it. One more minute. We'll go over it. Somebody here. Push. It should be 270, not 170. Okay. Justin, you're following along with stuff okay?
No, it was really open down.
So again, think about what angle measure it takes to go from 12, right, all the way around to 12:45. Say again? Probably, yeah, because we're almost done.
We had homework.
Yeah, this describes
That's right.
steroids.
Well, that really was my homework.
Oh my
I'm killing you? Nah, time's doing that. I'm just wasting it for you.
Well, yeah, you're wasting my time.
I'm wasting your time. Spending your time. Yeah, you're spending your time.
I mean, technically not intermediate or school, but like.
To graduate,
School's
yeah.
wasting our time.
School's
like
wasting
this,
our time.
because they're not wasting, like, they need to teach us, like, important stuff, like, indefinite math is useful.
It is.
I'm taking that one. That's useful.
It is.
I still need that.
If it's still around, I don't know if we'll still have the class around.
I don't know, some things I find useful in math, like problem-solving aspects of it are really useful. But like, what the hell am I gonna use to be able to find like circumferences of a clock and stuff?
Well, right, on a clock for sure, yeah. No, I understand.
They're making clocks all day.
That's right. Ah, this clock, I can tell.
Leo made a helicopter.
Still made a helicopter. Okay, here we go. Let's take a look at number 3 now. All right, so Chris, your number's up here, buddy. So, what is the measure of the arc here? How are we going to set this up? What's the formula?
Alright, so you do 270 degrees
270 degrees
divided by 360
over 360 degrees times
times parentheses 2 times 5 times 8.
the radius is 8, and that 37.68
Yeah.
inches. Okay, so it said round to the nearest tenth of an inch. So if you said 37.7, but I'm not going to take off if you didn't say that.
Oh wait, so you, if I did that one, I put it as test.
It'd be fine. It'd be fine.
the radius before that? So you gotta take half of 8.
Well, but think about this: the minute hand, right? Think about how the minute hand of a clock is located, right? It starts at the center of the circle, and it goes, kind of to the edge of the circle. So that is the radius. The minute hand is the radius, basically, because we're really saying here, we're not saying about for the entire clock. We're saying how far does the tip of the minute hand travel. So it's like the circle that the tip of the minute hand makes as it goes around. Because technically, the minute hand is not right to the edge of the clock, right? If you look at the clock up here, it doesn't go to the edge of the clock. It goes kind of like a certain. So where did you get 270? Great question, Chris. Where did you get 270 from?
You get it from 1245, which is
So,
3/4.
from 12.
So 360 is 270.
Right. So from 12 going around the circle, right, it goes to the 9 for 1245. That, as Chris said, is 3/4 of the circle. Now, what Chris didn't maybe realize here is he kind of like did double the amount of work. If he knew that that was 3/4 of the clock, all you actually really had to put out in front here was 3/4 times 2 times pi times 8. Because guess what? 270 divided by 360, guess what that simplifies to? 3/4. They're the same. No. No, which is fine. But you understand, that's the principle. You did, you kind of did work, you did more work than you needed to, but that's okay.
Not that much.
The key here at quantitative was to recognize that this was a 270-degree arc. It's 3/4 of the circle. So we don't want, if we don't include this part out front, if we just find the circumference, well, that's obviously the full way around the circle. But we don't want that. We want 3/4 of it, or 270 3/60ths of it, right? So another way you can figure that out too, Quante, is to realize that, well, if we want to find from here to here, we know from here to here, backwards, right? Backwards, that's 90 degrees. So you can do 360, take away 90, which is 270, and then add a 360. You can do it that way too.
Just doing that.
Yep.
Why are you telling us to, I mean, you were setting it up like that, so I did it.
Yeah, no, that's fine, but I want you to understand, what you can see though, once you understand the real principle, what's going on behind the scenes, you really just want whatever fraction of the circle.
You would have did 3/4 may not understood, because you've been
Right.
doing it now.
Using the arc measures. Right. But the real key is that really it's just 3/4 of the circle. So that's all you need to worry about. Okay? So, one other little thing I want to show you guys, and that is converting to radian measure. Converting to and from radian measure. So, radians are another way. So if you want to turn the page here to page 866. Okay?
Does that have to do with radius? Yes.
So in a way, yes, absolutely it does. So a radian is another unit that we use to measure angles, right? So just like if I want to measure the length of something, I could use inches, or I could use centimeters, or I could use meters, I could use feet, whatever, right? Same idea with angles. Angles we can measure using degrees. We can also use something called a radian, okay? And so the way we figure out what a radian, okay, is the number of radiuses it takes to kind of go around the outside of a circle, or that's kind of like where we come up with radians, okay? So for example, to figure out, you know, what the degree measure of a circle is, let me just kind of do this over here to the side. So for example, we know the full distance around the circle with degrees is what? How many degrees does it take to go around the full outside of the circle? 360 degrees, right? But we also know, what's another way we have to find the measure around the outside of the circle? Besides 360 degrees, what else do we have? The circumference. What's the circumference formula?
Wait, the same thing we just did?
What's the circumference formula?
Is it the thing is it
S equals M over 360.
So we're just going to have the 2 pi r, right? Because we just want the circumference, that's the full circle. So 2 times pi times the radius, there's our circumference, right? So in a way, 360 degrees, which goes around the full outside of the circle, is the same as 2 times pi times the radius, right? Because that also goes the full distance around the outside of the circle. Yeah?
I swear, not the radian measure, but we learned like how to find like circumference before.
Well, yeah, I'm sure you have. Yeah, we talked about it before.
Like before, like
This class? I'm sure you have. Yeah, I'm sure you have. Yeah, yeah. So, but this is a new way now to kind of come up with a different unit of measure for angles. So, if 360 degrees is equal to 2 pi radiuses, so what that means is that if you were to if you were to make any sort of circle, if you were to mark off that radius, okay, it would take about 2 pi, which is about 6, right, because pi is 3.14, so times 2 is about 6. It would take about a little over 6 of those radiuses to go around the outside of the circle, okay? So these two things are essentially mean the same thing. Which means then that if 360 degrees is equal to 2 pi radiuses, right, we can also say it's the same idea as 360 degrees is 2 pi radians. Okay, so this is where the radians come in. So 360 degrees, the full distance around the outside of the circle, is the same as 2 pi radians. Okay, so that's our unit is radians. So here it's degrees. 360 degrees goes around the outside of the circle. 2 pi radians go around the outside of the circle. Which means then 180 degrees, how many radians is that? If 360 is 2 pi radians, what would 180 degrees be? How many radians? 1 pi radian, or just pi radians. Yes, how'd you come up with that, Lamel? Yeah, 360 divided by 2 is 180, right? So 2 pi divided by 2 is just pi radians. So 180 degrees is the same as pi radians. And this is the key relationship to remember. 180 degrees is pi radians. So, for example, if I want to convert, 180 degrees, so the directions here, okay, in the example, convert each angle measure to radian measure. Well, if I want to convert 180 degrees to radians, well, what do we know? How many radians is 180 degrees? 1 pi, right? 1 pi. So just pi radians. So it's just going to be pi. That's an easy one. Okay? But what if I want to convert 60 degrees to radians? Well, here's how I'm going to set it up. I'm going to say 60 degrees, okay, over x. I don't know what the number of radians is here, but I know that then that'll be the same proportion as 180 degrees over pi. Okay, so we set up a little proportion here. We use a known angle and radian measure, 180 over pi, and that equals then our angle 60 over their radian measure, x. Okay? And then how do we solve this proportion? How do you solve any proportion? Cross multiply. So we have 60 times pi, so that's 60 pi. And we're going to leave the pi out. We're not going to multiply it through. And then 180 times x, 180x. All right, what's our last step here to get x by itself? Divide both sides by... Yeah, what's with the x? 180. So we're going to divide both sides by 180. So the 180's cancel, and we get x equals... Now, 60 over 180, we could leave it, but that simplifies, doesn't it? 60 over 180, that simplifies. If I type that into my calculator here, 60 divided by 180 is 1/3. So this is really equal to 1/3 pi. And that's our final answer. So 60 degrees is the same as 1/3 pi radians. Okay, same thing. All you did was just set up a proportion and cross multiply.
So like we'll be doing for the last like few years.
Yeah, been using that a lot. That's, you know, again, you see it show up again. That's why it's so important. All right, so let's do two more here, and then I'll get you guys started on your assignments. Okay, 2 more, and then I'll be done talking. Okay. So number 7 and 8. Let's take a look at these. So these both are. I know they're your turns, but we're going to do them together. Just some more practice. So it says convert each angle measure to radian measure. So 90 degrees. So again, we'll start off 90 degrees over x. We don't know what that radian measure is that it matches up to. That's going to equal, though. Again, what's our ratio that we know? Well, 180 degrees matches up to how many radians? 1 pi. Pi radians. So we're going to put a little pi there. Just 1 pi, or just pi. Yep.
Can it just be 1/2 pi radians?
Not 1/2. You're on the right track. Oh, I'm sorry. Yes, it would be pi over 2. Yes, it would be 1/2 pi. Exactly right.
Really?
Yeah, you're right. Good job, Chris.
I just figured it out of my head.
That's good. Good job.
Yeah, you told me I was wrong.
Sorry, I had to yes, you're right.
I was like, what?
That's right. So we multiply here, cross multiply. 90 times pi is 90 pi. X times 180 is 180x. Okay. Divide both sides by 180. And Chris is right. 90 over 180, that simplifies to, excuse me, 1/2, or 1/2 pi, because there's still the pi. Good job, Chris. Good.
So, I mean, if you don't have,
If you can just figure it out like that, you don't have to do the cross
so it's
multiplication.
45 degrees, it would just be 1/4.
1/4 pi.
Well, you can't really break it down more than that, because that would be a decimal.
Yeah, if it was like 22.5 degrees, then it would be pi 8,
Yeah,
pi over 8.
The most you can get is like it's down to 45. But if it's like uneven,
You can also do like 30 and 60 as well.
I mean, if you can't if it's like uneven where you can't figure it out, then you can just do what you just did.
Well, so we'll talk about that. Let's do this last one here, and then we'll talk about what you're thinking about, because you're on to something. Okay. So yep. So 45 over x. Again, we have the 45 degree angle. We want to convert it to radians. So we don't know that number of radians. We're going to figure it out, and we're going to set it equal to, again, a known degree in radian measure. So 45 degrees over x radians. We don't know what that equals. That must equal the same proportion, 180 degrees over pi radians, right? So we cross multiply, and we get 45 pi equals 180x, right? Divide both sides by 180 again.
Wait, if we already know,
And that's 1/4 pi.
If we didn't show work,
If you can just figure it out, that's fine.
because I already know what that is.
Okay, that's fine.
Do you want us to write radians out every time?
You don't have to. If you just leave it, but don't put the degree symbol. If you don't put the degree symbol, I'll assume you're using radians then.
Just
But you can also put radians too. That's fine too.
Alright, but we could just say x equals.
Yep.
Just say,
That's fine.
yeah. Wait, we don't have to say x. Right? Because I was putting I put 1/4.
That's fine. That's fine. Now, so Chris is onto something here, right? So he was able to figure out, maybe some of you guys were, that, or ladies, you got gentlemen, ladies and gentlemen, all right? So if he knew that 180 was pi radians, well, half of 180 is 90, so that means that would be 1/2 pi, right? So 1/2 of 180 is 90, so 1/2 pi. And then 1/2 of 90, right? So 90 degrees was 1/2 pi radians. Half again is 45, so half of a half is 1/4 pi. But what about something like 30 degrees?
Then I have no idea. You'd have to say.
Well, again, what fraction is 30 of 180? It's not 1/3,
Wait,
1/6. Or you could say it's 1/3 of 90. Is that what you're saying? Is 1/3 of 90? 30 degrees is 1/3 of 90.
And then you just
Multiply 1/2 by 1/3, which would be 1/6. 1/6 pi, so pi over 6, or 1/6 pi. Okay. Or you could say if 30 degrees is 1/6 of 180, right? 30 is 1/6 of 180, so again, be pi. 1/6 pi is the radian measure there.
360, it's 2 pi radians.
Mm-hmm.
Whenever it's 180.
It's pi radians.
For 1.
Mm-hmm.
And then, yeah, you just
And then you just do the fraction of it from there.
Yes.
Or you can use the proportion.
Which would be 90 and, yeah.
Okay.
But if you know, you can just